Hi guys, we are back with chapter 9. We're looking at transformations. Today specifically we're going to look at reflections. So by the time we're done with our lecture we should be able to do reflections over given lines. So let's take a look. We are 2-5. So essentially we need to understand that when you reflect across a line, each point maps to another point the same distance from the line, but on other side. Okay, so when we are reflecting across a line, each point maps to another point the same distance from the line, but on the other side. Remember, when we talk about distance in geometry, it means the perpendicular length. So distance deals with the perpendicular segment. So if we take a look down here, we can see that this is my line of reflection. So I took my original figure and mapped every one of the vertices on the other side at the same distance. So if I look at just B, B needs to be the same distance away from the line of reflection at a perpendicular distance. So whatever this measurement was is the same as this measurement over here, and that's how I get B prime. What we need to notice about that's different about reflections and translations is that reflections reverse orientation because we're flipping it over the points reverse. So if I talk about my pre-image triangle BUG, if I start with B and I go to U and then I go to G, that's all clockwise stuff. But if I reflect it over this vertical line, I don't know, some sort of X is equal to something, it's called X equals 1, then I get my image of B prime, U prime, G prime. But when I take a look at them here, if I start with B, I still got to go to U next because it's corresponding positions, just like in similar and corresponding or congruent figures. We're looking at U to G is now counterclockwise. So when they talk about orientation, that's what we're talking about. Visually, in the setup, when I read through my corresponding vertices, they go in the opposite direction, or the reverse orientation. So let's jump right in. We want to reflect across a line. So a reflection across a line deals with a reflection across a line M, you could call it whatever you want. Call M, N, P, Q, X equals whatever. Is called, the line M itself is called your line of reflection. And we abbreviate that line of reflection. Line of reflection is a reflection across a line of reflection is a transformation with the following properties. If point A is on the line of reflection, then A is equal to A prime. So if we go back up to the example above. So if we go back up to this example, my original A, my pre-image A, is right here on this line of reflection. So it needs to be the same distance away from that line of reflection when I reflip. Well, if it was 0 distance away to begin with, A prime has to be 0 distance away, and therefore A becomes A prime. So if it's on the line of reflection, then you know that point is the same exact point after you reflect it. If point B, or whatever point we're talking about, is not on the line of reflection, then point B then the line of reflection is the, sorry about that. If B is not on the line of reflection, then the line of reflection is the perpendicular bisector of B, the segment B, B prime. So if we go back again at our example, B is not on the line of reflection, so the line of reflection, which is right here, becomes the perpendicular bisector of this segment, B to B prime, which we had already said has to be equidistant from the line of reflection. So my line of reflection chops the segment B to its image of B prime in half at a perpendicular segment. So these are easier once we get them rocking and rolling than to talk about the general English. So we'll go back to that. So you write the reflection across M that takes B to B prime as, so if we're just talking about looking at this reflection of the point B, reflection, just like our translation was a capital T, our reflection is designated as a capital R, sub M of B as B prime. So in this case, this sub M is the equation for the line of reflection. So just like before we had a vector for a translation where we moved some stuff up and down, this sub behind the reflection tells me that what line of reflection I'm going to use. So that's my line of reflection. So let's try one. Graph reflections in horizontal and vertical lines. So we're going to start with some easy ones where my lines are just my lines of reflection or horizontal lines and vertical lines. So I'm given graphs A, B, and C. So A, B, C, so it must be a triangle. It says graph and label, big R means reflection. Y-axis is my line of reflection, and this triangle ABC is my pre-image. My original image before I've reflected over the line of reflection, Y-axis. So where do we start? We start with step 1. Graph triangle ABC and dash your line of reflection. So step 1 is to graph my preimage. So my A is at -2, 1, 2, 1, 2, 3, 4. So there's A. B is at 0, 1. There's B. And C is at 1, 2, 3, 4, 1, 2. So there's C. That is my original or pre-image figure, triangle ABC. Then it says to dash in my line of reflection. My line of reflection is the y-axis. So I need to go to the y-axis and put some fat line of reflection up above too so it goes off and label it line of reflection. So that's my line of reflection. That's the line that I am flipping this triangle over. It's holding its position and just rotating around that line. So in a three-dimensional figure, that would start to spin all the way around. Okay. Step 2 is to find A prime, B prime, and C prime. So remember, they are perpendicular to the line of reflection at same distance. So A, perpendicular to the line of reflection, is 2 units away. So I take A and I move it on the other side of the line of reflection 2 units to get A prime. And I do that with all of them. When my lines are horizontal and vertical lines of reflection, I just look for the perpendicular and swing it over. So if I'm going down to C, 1, 2, 3, 4, perpendicular to the line of reflection, it's 4 units away on the right, so I need 4 units on the left. 1, 2, 3, whoops, didn't give you a big enough graph, so I'll add it in over there. That becomes my C prime, because it is 4 units to the right of the line of reflection, so it needs to be 4 units to the left. B is right here on the line of reflection. So remember, when I'm on the line of reflection, I'm 0 units away, so this also becomes B prime. I found each of my prime vertices, so step 3, connect A prime, B prime, C prime to get triangle A prime, B prime, C prime. Highlight. We're going to get in the habit of highlighting our images so it's easy to see what my transformed image position is. This transformation happens to be a reflection over the line x equals 0 or the y-axis. So that becomes my reflected image, and I'm going to highlight my reflected image. Okay, not too bad. So let's try another. So let's take a look at the second page. It says, hey, the vertices of triangle ABC are blah. Graph the reflection as described. So remember, capital R means reflect. This is my line of reflection. This is my pre-image. And so this becomes my image. Step 1, I need to graph the first one. So my pre-image is A at 1, 2. 1, 1, 2. So that's my A. B is at 1, 2, 3, 0. And C is at 5, 3. 1, 2, 3, 4, 5. 1, 2, 3. So that's C. So my pre-image is now graphed, and I need to put my line of reflection in. So my line of reflection is x equals 2. X equals 2 is a vertical line at 2. So my x equals 2, 1, 2, is my vertical line at x equals 2. I dash in my line of reflection. That means I'm going to flip this triangle around this line of reflection. Step 3 is to find my prime points. Those are the perpendicular equidistant. So if I'm just looking at C, C is 1, 2, 3 units away to the right, so it needs to be 3 units to the left. 1, 2, 3, so that's C prime. A is on the left 1 unit, so I'm reflecting it over to the other side. I get A prime. And B is, where is B? 1 unit to the right, so it needs to be 1 unit to the left. B prime. The last step is to connect my prime points. I should end up with a figure that is the same exact shape and size, only with reverse orientation. So graph it and highlight your image. Your final image should be highlighted. Okay, let's try the next one. R means reflect. Y equals 3 is my line of reflection. Triangle ABC is my original pre-image, and this becomes my image after it's reflected over y equals 3. So I start by graphing the original triangle, which we already know where the original triangle is. It's 1, 2, 1, 1, 2. That's A. 1, 2, 3, that's B. And 5, 1, 2, 3, that's C. So if I'm going too fast, you pause the video, you catch up with me, and we go from there. So we should know how to graph. That's my pre-image. says to graph your pre-image and then drop in your line of reflection. Y equals 3 is a horizontal line, 1, 2, 3, at y equals 3. So I need to dash in my line of reflection. And as we can see, my line of reflection passes through point C. So C prime is going to be the same thing as C. Next step is to find my primes. So we'll start with C. C is on the line of reflection, so C is going to equal C prime. A is 1 unit below the line of reflection, so A prime needs to be 1 unit above the line of reflection. B is 1, 2, 3 below the line of reflection, so it needs to be 3 above. 1, 2, 3 above the line of reflection, B prime. My reflected image over y equals 3 looks like that. So I connect the points and I shade it in as my final image. Sometimes we have figures that are being reflected, sometimes we have just plain old lines that are being reflected, sometimes, such as example 3, it's just a point. A point P has coordinates 3, 4. So I want to graph 3, 4. 1, 2, 3, 1, 2, 3, 4. So point P is right there. But it's asking me what are the coordinates of a R, which is reflect. Y equals 1, that's my line of reflection, of the point P such that I get P prime. So if my line of reflection happens to be y equals 1, which means it's a horizontal line, here, I could graph it. I need 1, 2, 3 above, so 1, 2, 3 below would give me my reflected point. But we can do this stuff algebraically as well. This tells me I need 3 points above line of reflection. So P prime is 3 points below line of reflection. So in this case, my X is not changing, right? I don't move my point left or right. So X is the same. In this case, my original X was 3. So I know I have a point at 3, and then I just have to figure out what my point is for the reflected Y. So Y is going to equal, wherever my line of reflection is, 1, take away the 3 points behind or below that I need. So my line of reflection is at 1, but I need to be 3 below that line. So subtract 3 equals -2. So that means P prime is going to be at 3, -2. Okay. You are going to work on the practice problems. There are 1, 2, and 3. I shouldn't show those yet. One more on the next page. So pause your video, check those out, and then replay to check your answers. Okay, there are the answers for 1 and 2. 1 should be reflected over this horizontal y equals 3, so you should get an image above here. And since we're reflecting this point over x equals 1, it's a vertical, so my y doesn't change. My x changes, and you should get the point P prime, -2, 4. If you did not get that, pause these now. Make sure you understand what's going on. Fix your work. And then your final practice problem was this reflection over the x-axis. There are your answers for that. Pause the video if you did not get that right, and let's see how you do. Alright, so let's take a look at general properties. So this is all the properties we talked about. The fact that if you reflect, you get the same distance, preserves distance, it preserves angle, measures, all that good stuff. Since no shape changes, I don't get bigger, I don't get smaller, I don't change my angles or any of that, I know that all these properties end up meaning that reflections are rigid motions, also known as isometries. Remember that from last lecture? So I did not change the shape, the look, the size of the figure, therefore it's a rigid motion. Okay, so that's what all those properties lead to. Alright, let's try reflecting in non-horizontal lines. So I'm going to graph and reflect over y equals x. This is not horizontal or vertical. So it makes us have to put on our thinking caps because we still have to be the same perpendicular distance away from the line of reflection. Not as easy to do now that we have a non-vertical line. The steps are the same though. So we are going to, given the endpoints of segment CD, so we're just doing a segment now. These are the endpoints, so our first step would be to graph CD. We're going to reflect it over the line y equals x. If y is 0, then x is 0. If y is 1, x is 1, so on and so forth. So the line of reflection for a y equals x is the slope of 1, and it runs through your origin such that y equals x. So I don't have a vertical line anymore. So let's go ahead and graph our original segment, our pre-image at -2, -1, 2, 1, 2, and 2. That's C. D is at 1, 2, 1, 1, 2. So our segment is a horizontal segment with those two endpoints. We want to reflect it over the line of reflection. So let's watch about what it looks like once I reflect it, because it gets interesting when you're just reflecting a segment. It kind of messes your brain up. But let's recall that the product of slopes of perpendicular lines, if I have a slope of 2/3 and I multiply it by its perpendicular, it's always going to come out to -1. So since I have a line of reflection, y equals x, its slope is 1 over 1, which is 1. The segment from C to its image, C prime, is perpendicular to the line of reflection, y equals. So remember that the segment, we need perpendicular distances. So the slope of C prime, since I want a perpendicular, if this is 1, the slope of C prime needs to be -1. Because 1 times -1 equals -1, 2. Because I need its perpendicular slope. So I know, if I go over to my line, that from C to C prime, somewhere over on this side, that line of that perpendicular segment between them has to have a slope of -1. So down 1 over 1. If I plotted a point right there and connected it across, I'm going to do it real light, then I am going to hit C prime at some point. So I'm going to just dash this in and see how we end up doing. I know that the perpendicular segment between the original and its prime number is going to be congruent. So I know that this piece here has to be congruent to this piece on this side to find C prime. So from C, I have to move 1, 2, 1, 2, 2 units right and 2 units down to get to the line of reflection. So from the 2 over 2 down, I'm at this point. So to find it on the other side, I do the same exact thing. I move 2 units right and 2 units down. 1, 2, 1, 2. That's perfect because that's where I had expected it to find it on the perpendicular segment between those two numbers. So that is C prime, which happens to be at 1, 2, -2. So 2, -2. Do the same thing for D to D prime. So we know that the slope of D prime, the segment between the pre-image and its image point, will also need to be -1. So if we just kind of ballpark in -1, -1, my -1 slope, so if I put it between those 2 points, I should end up somewhere on that perpendicular. To get over to this line, I moved over half and then got down half. So I moved right 1/2 of a unit and down 1/2 of a unit to get to the line of reflection. So I need to continue that same pattern. I move right 1/2 and down 1/2, and I end up with D prime at that position right there. So I do the same process to get to the line of reflection and then pass the line of reflection to get to my prime. So I get D prime located at 2, 1. Well, when I connect C prime and D prime, I end up with an image that looks like that. So when you're thinking reflection, I think that's a weird looking thing, but it means this piece is equidistant from this piece across the line of reflection as this point is here. These take some practice, you'll get the hang of it, so don't stress about it. Alright, so let's take a look at our next page. The last page gives us our cheat sheet ways. These are our cheats for when we have specific lines of reflection. We can always use the method that we just used before, where we moved the same direction left and right, up and down between the line of reflection to get to our next point. But our cheat sheet says, hey, if A and B is reflected over X axis, its image, which means its prime, right, is a -B. Well, what changed? Keep X, flip sine of Y. That's all that means. So if I have a reflection over the Y axis, its image is the point -A, B. So keep Y, flip sine of X. If I'm reflected over Y equals X, so it's a positive slope, +1 slope, its image is BA. I just switched the position of A and B. Take whatever those values were in the point and flip them. And then if I have Y equals -X, so that means I have a slope of -1 for my line of reflection, it means to switch the position and the sign of your X and Y. So let's try a couple. These aren't so bad. So Y equals -X. So I take a look at my list. Oh, look. That means I'm going to map AB to -B, -A. That's just the same thing as X and Y. They're the same values. So if I'm given the segment C, which has -2, 2 as its point, I'm mapping to C prime, I need to switch the signs and the position of A and B. So I switch the position of A and B, well, they're both 2, and I switch the sign. B was positive, it becomes negative. A was -2, it becomes positive. That is C and C prime, so let's take a look at D. So I got D is 1, 2, because they gave it to me. I'm going to map it to D prime such that I change the sign of B and it comes first, so I get -2. Change the sign of A and it comes second, so that's -1. Then I can plot all this stuff. So my original is -2, 2, -2, 2. That's C. 1, 1, 2. That's D. My line of reflection is Y equals -X. So when Y equals -X, it's the line of reflection with the -1 slope that goes through the origin. So I've graphed my line of reflection, and I can plot my prime points. -2, -2, 1, 2. Oh, well, that makes sense because C's already on the line of reflection, so that means C and C prime are the same point. D is -2, -2, -1. D prime connect my primes. Should probably connect my original segment as well. And the primes become my reflected image. Good? Alright, you've got a couple below, so pause the video and then go ahead and give those a try. When you're done, start your video back up. Alrighty, so you have practice problems below. Those are your answers. That's what your figures should look like. If they do not, pause the video and then check your answer, see what happened. Okay, so those are those two. And let's see, where we got? We got one more piece. Nope, that's it. I will see you in class.